Okay, so we're walking down. This is the exhaust side, basically, of the wind tunnel. Whoa, is this okay? It's a field trip. Do you ever go indoor skydiving? I've done it once, recently, I guess.
Yeah, we have one around here that can do that.
Yeah. Wow. Well, I'm not a small person, but this is pretty huge. We're walking through the fan. Okay. So we're going in the direction of the wind. Basically, the wind is going this way. So yeah, and then the air goes this way. Wow, this is humongous. So why am I walking inside of a Ford wind tunnel? Well, I've been wanting to do this video for a very long time because I've been very curious about how do manufacturers test, develop, and validate brand new pickup trucks, or actually any vehicle for that matter. And this is it. So in this video, I am in Michigan and I'm at a Ford facility. And this is super high tech. And I had no idea that it's gonna be this detailed and this involved to test a tire change on a Ford F-150 Tremor off-road truck. So in this video, you will see a bit of how it's done and actually how cool this wind tunnel facility actually is. Because if I think back to what I used to know about wind tunnels, I'm envisioning a static vehicle, or car or truck, sitting in what I think is a wind tunnel with a fan blowing air on it. And you could see some smoke, maybe white smoke going around it, and a bunch of engineers looking at the smoke. But I was very wrong. There's a lot more to it. And of course, technology has improved so much. And now this wind tunnel has a rolling road. Basically, the wheels are turning, so it's mimicking exact highway conditions. And the entire table on which the truck is sitting can also rotate. And so you can kind of do side wind testing as well. And this just shows how complicated some of these items are. And Ford is going to great lengths because they're considering about changing their all-terrain tire or adding another choice for the F-150 Tremor, but they want to validate that it's not going to affect in a negative way the fuel efficiency of that truck. So they're going through all this computation and then validation in this environment. And actually, I'll show you smoke in a second. So let's go and kind of look at the truck actually rolling on the rolling road inside of the wind tunnel, and then let's see how it progresses. So Rafael, can you just explain this room? Because this is a gigantic space.
Yes. Well, this is what we call the rolling road wind tunnel. It's used for development of all the vehicles that we produce. It's basically blows the wind from a big fan that's in the opposite wall.
So this is a gigantic fan, probably the size of that black wall, right?
Yeah, almost that. Yeah.
Like the diameter of it, right?
Yes.
So this is what, like, I don't know, 20 feet in diameter?
Yes.
Okay.
It's a big one.
So
yes.
the fan is somewhere over there,
yeah.
And it kind of directs the air through?
That way, then it makes 2 turns before getting here. So then the vehicle is here, the wheels are spinning, the floor is moving to represent the real physics, and the wind blows, and the tires are on special pads that are connected to a big balance system that's underneath. So that balance measures all the forces in all the 3 directions. In the same direction of the wind, which is what we call the drag. It measures the vertical forces, which we call the lift. And it also measures lateral forces, in case you want to see like crosswind conditions.
So you can simulate up to what speed? I mean,
this
like
tunnel
highway
here,
speeds?
Yes. Our typical tests are done at about 80 miles per hour.
All right.
That's what we test.
Yeah.
So we test, sometimes we go down to 60, we go up to 100, 120. The capability of the tunnel, I can confirm with the wind tunnel supervisor, but I think it's around 180 miles per hour.
Okay.
Yeah, so we have Ford Racing testing here as well.
Right. So it's not just obviously trucks. I mean, it's everything.
We test
every vehicle.
Every vehicle that we produce goes through this tunnel. Yeah, the ones that are developed here in North America. We have a similar wind tunnel in Germany as well, where the Ford of Europe develops their products.
So this can we walk up to this
Yeah, sure.
a little bit?
Yeah.
So this is kind of the rolling road that you said?
Yes.
Right, this part?
Yes, because in real world, the air is at the same speed as the floor.
Yeah.
Right? Unless you have some wind.
Yeah.
So here, the vehicle is steady.
And it's attached.
We have to make everything else
attached
to move.
right there, right?
Yes. Yeah.
With
So
these
it's
four
connected.
rods.
Yeah, it's connected through the frame.
These guys. Yeah.
Yeah, it connects to the frame. The guys in there, they can lift the vehicle. They can bring it down. We can adjust the attitude.
Okay.
If you want to simulate it a little higher, or a little lower.
Or maybe
if you have
some
a big load,
yeah.
you can squat the vehicle down.
Okay.
We can test at those conditions. So.
And then the wheels are spinning as we were watching
spinning, everything at the same speed. The wind comes, everything else rotates at the same speed. The ground will move at the same speed. The wheels will rotate as if the truck was on a highway.
And then the whole table, this kind of metal part, can rotate itself as well, right?
Yeah.
So you could have a crosswind and
exactly
those conditions, huh?
Yes, that's right.
Wow. So then, why is this F-150 Tremor here?
Well, we are very diligent in terms of getting the right numbers, the correct numbers, especially because aerodynamics fits into the fuel economy. So this truck, it's a Tremor, but it still has a fuel economy label to it. The customers want to see that. So today we are testing a different tire that is coming out. We want to make sure this tire is not worse than these current tires. So we are testing here. In a bit, we will be replacing these tires with the new ones, and then we will be able to compare both in terms of aerodynamics performance, and then we will know, okay, this tire is worse or it's equivalent, it's better, and then we can communicate that back to the fuel economy team and see what the next steps are.
Nice. So this is a kind of a current 2026 or 2025
F-150
Tremor, and it has a suspension lift. I mean, it doesn't have a chin spoiler because it's an off-road truck.
Exactly.
And it has these 33-inch diameter tires.
Grabber tires, yes.
Grabber tires. And
Very off-roady, yeah.
Exactly. So, but there's a lot of air that actually hits the tire.
Exactly.
Right?
Yes.
So it's a little bit more sensitive to...
Yeah, the tire is more exposed. The tire is a little bit wider as well.
Yeah.
And it has all those features on the sidewall. So everything kind of adds to the drag of the vehicle, right? So on these configurations, especially when you don't have that air dam on the front, which is more for off-road, right? We want more ground clearance.
Yeah.
So yeah, the tires end up being a big thing, and we want to make sure we get the correct numbers.
That's very interesting because I thought, the tire has to do a lot, right? The tire is usually rated for the weight of the vehicle, the capability of the vehicle, also the ground clearance. So the manufacturer, for example, Ford would work with the tire manufacturer, right?
We do.
And they would do the compound, the strength of it, the construction of it.
Yes.
But then what was missing from my mind was, okay, I thought it was just an estimation of efficiency, but you were actually very precise.
Yes.
With this. And the size of this tunnel is just insane.
Yes.
This is crazy.
It's pretty big. Yeah. Our old wind tunnel is right next door. It's like, I don't know, maybe 60% of this size. And it didn't have the moving belt capability. So we opened up this one here back in 2020. Pretty big deal for the company. We are able to do very good stuff in here.
Okay, so I'm gonna let's get out.
Yes,
because we need to do some more work, right?
Let's keep testing.
Okay, let's do it. So the guys are swapping tires and they're putting this new Pirelli Scorpion XTM AT all-terrain tire. It's also snowflake rated. So this is a pretty robust tire. It looks good, but it also should be quite capable. But it's not just a fact of like now selling these tires on a truck. They're doing a lot of testing to actually validate, make sure it doesn't affect the fuel efficiency that much, if at all. Or maybe it could improve it. I mean, it could go both ways, but you have to test to find out. And I know manufacturers do a lot of testing, of the tire manufacturers do so, and also, of course, vehicle manufacturers are doing even more testing. I'm just surprised and impressed about how much testing and work goes into this. So what you see now is they swapped the tires, actually dismounted the previous tires, mounted the new tires. These are the Scorpions. And then they're going to install the vehicle back onto the wind tunnel and the rolling machine here. So there's a laser that's in the center, so the vehicle is centered. It's also on the grill of the truck. So they know that the vehicle is exactly where it used to be, and it's centered. And now they're attaching it to the devices that measure the forces. Because the vehicle's attached at 4 points there, and they're measuring three-dimensionally the forces that are applied by the wind. So what you just saw there is about a couple of hours of wind tunnel testing. So first some testing, then changing the tires, and then starting of another validation run. But I wanted to see smoke because that's kind of my visual image I see usually in my mind when I think about wind tunnels. And actually, one of the engineers there said something very interesting, which is just as a human looking at a bunch of smoke going around the vehicle, yes, it's some sort of a validation, but it's really hard to know because it's not very accurate, because our eye can only see so much, and if you see turbulence around the vehicle, it's hard for a human to understand it. So before it ever gets to that place, there's a lot of computations and modeling and 3D modeling in the computer, and then what's happening in the wind tunnel is actually some validation of what the computer models have predicted. And also, it's really important that the rolling road on that wind tunnel is also there because it basically mimics real-world conditions as close as possible. So let's take a look at us actually seeing the smoke go around this F-150. So the reason why we're here is because for the smoke demonstration, the wind speed is not very high, right?
Correct. Yeah.
What's the wind speed?
Between 30 and 35 kilometers an hour.
Okay. Kilometers per hour.
Yeah.
So that's why we're here and we're wearing protection for our eyes. Okay, so now the reason why the smoke is green is because there are several lasers that you've seen before in this video, kind of centering the vehicle long ways and also in profile. And guys with that wand where the smoke comes out can actually kind of put the smoke within that laser's path so you can actually see that color, and that smoke is a little bit more visual so you can actually see it a little bit better. And the speed of the wind, you saw that, wasn't super high. So this wasn't a highway scenario. It was about 20 to 25 miles per hour. But nonetheless, you can kind of see exactly what's happening. And over the hood, it's really nice and smooth, and also over the cab, it looks perfect. But then I was interested in two things. First of all, what happens after the air leaves the cab and goes into the bed? Because usually that's where a lot of controversy is. Do I need a tonneau cover? Will the tonneau cover help my fuel efficiency? What if my bed is shorter or longer? What's going to happen there? So I really was curious about that. And the second thing I wanted to know is what happens on the side of the vehicle. Because usually when you're driving, you hear the wind noise over the side mirrors and sometimes over the tires. There's a tire noise, of course. But it was really cool to see when they put the smoke on the side of the vehicle, what happens. So let's talk about the bed really quickly first. First of all, in this condition about 25 miles an hour, you could see the smoke actually going all the way over the bed. So it actually never touches inside of that bed area. And this is a 5.5-foot bed, which is the most common configuration for pickup trucks in the entire country. Basically crew cab with a shorter bed. If your bed was longer, 6.5 feet maybe, or even an 8-foot bed, which some work trucks and heavy duty trucks have, the results would be different. But for this example with the F-150, I could see the smoke going all the way around. There's a little bit of turbulence, but it doesn't seem to be, getting hung up in the bed, which is kind of interesting to see and very cool, at least for this lower speed scenario. So in this case, the tonneau cover would have no effect. In fact, it'll be adding weight to the truck and having other maybe possible effects. And then when the smoke went on the side of the truck, you can immediately see some turbulence occurring. And turbulence usually means bad stuff, or it can mean, that there's a little bit more resistance, the air is unstable, you might be losing efficiencies there. And there's not a lot you can do because the tires are so exposed and they're large, they're 33-inch diameter off-road all-terrain tires, and you immediately see turbulence around it. So at least for me, that was really interesting to see. And also, more importantly, I got to experience what you would think would be a small change for Ford, right? Changing one brand of tire to the next brand of tire that looks, has similar traction or similar tread pattern maybe, but the lengths they go to actually validate, verify it, make sure it doesn't affect fuel efficiency in a very large way, or maybe it's actually better, who knows? So they have to compute all this data, all these numbers, so that when you're buying your brand new pickup truck, you can be sure whatever it says for that particular model on that sticker was actually tested and is relatively accurate, or as close as being real-world accurate as possible. Let me know what you think in the comments below. Thanks for joining me on this video, and I'll see you next time.